Why? This man's technology. USPS, UK Postal Service, most of the postal services globally use the technology he developed for pattern recognition and character recognition. Gosh, how many decades ago? So USPS still uses this technology. So before language models were a thing, Venu was a thing. So thank you, Venu, for joining us today. And he's had an amazing career for 3 decades at University of Buffalo. And every time he thinks he should look at some other option, Buffalo says, no, you're staying. And the portfolio responsibilities keeps increasing. He is, and notably so, his research projects have led to more than $100 million of research funding. And he's also, despite being a VP of Research and Economic Development, he finds time to write grants, and he's the lead PI of an AI institute by NSF, largely on National AI Institute for Exceptional Education at University of Buffalo with collaboration with various other universities, but Buffalo is leading it. And it really is another great example of AI for impact on how AI is being for children literacy and education. And that has also spun up another grant with the Department of Education at Buffalo. So it's really building on huge impact in many ways. And then he's also, I believe, a co-chair of, so the state of New York has pledged about, in collection with the consortium of universities, $400 million, what they call Empire AI. Which includes the SUNY system as well as the private universities, which would lead to a $250 million computing infrastructure at Buffalo that Venu would be overseeing. So, that's also part of his portfolio, and as well as a $450 million research enterprise. Buffalo is a member of American Association of Universities that we are delighted to be your colleagues and peers there, Venu as a university. And then in addition, he's the fellow of AAAS, fellow of ACM, fellow of IEEE, fellow of IAPR, and fellow of National Academy of Inventors. So Venu, please, thank you so much.
My eyesight isn't very good, so I'm trying to coordinate it with my laptop over here so I can look at the slides too. All right, good afternoon, everyone, and I thank you so much for that warm and generous introduction. And I promise you that I will keep my presentation to the non-technical extent that is possible, but at the same time keep it interesting. When we talk about evolution of AI, which is the title, and so evolution means things are moving hopefully in the positive direction, but then my office staff also likes to put my picture over there, and I don't think the face is going in the positive direction. So that picture is also a couple of decades old. 30 years back, when I was doing my PhD in computer science and engineering, artificial intelligence was not the coolest thing in those days. We would work with toy problems, and those who were working in operating systems and compilers and databases and networks and algorithms and theory, they all thought that we lacked the rigor. And look how the world has changed, and what a sweet revenge for all those who worked in AI in the early days, and now everybody's on the bandwagon, right? I mean, everything, any engineering, anything that you do is all AI. So I thought I will start with the history of AI. So going back to computing itself, from the 50s when Alan Turing coined the term artificial intelligence and defined it as something where if you can have a conversation with a machine And the machine can essentially fool you into thinking that it's actually a human being on the other side, then it qualifies as having intelligence. And so today's chatbots, almost all of them, I'm sure, qualify as being artificially intelligent. And then if you fast forward, today in the era of generative AI and chat GPTs, there is almost 70, 80 years over there. And right in the middle, you see I have highlighted 1997, and as was mentioned by Nitesh, we like to believe, and and there is support for this view as well in the community, that we delivered the first machine learning success story in the real world. So alongside with IBM, which came up with the chess playing program, which could defeat the grandmasters, at University at Buffalo, we pioneered the technology that would read handwritten addresses. So for the last 30 years, whenever you wrote something on an envelope, an address, and put it in the mailbox, I know it's not that common nowadays. It's everything by electronic emails and so on. But even once in a while, when you put in a greeting card, handwrite the address, that is read by a technology that was pioneered in our labs. So that was one major success story. So, and both sides, the neural networks, which came about in the 70s, and then the backprop algorithm, later on, so that the machine could learn. And then, the confluence of data, sensors, and storage becoming cheap. Fast forward to, let's say, 2009, 2010, the release of the ImageNet, millions of images, photographs available for learning. All that contributes to where AI is today, in terms of what we are looking at and hearing about every day. But I just wanted to point out that we had indeed a role to play in all of that. So I wanted to give you a quick understanding of how we solved that postal address recognition problem. Because if you think about it, sometimes we take handwritten notes. I still see some people will open a notebook and write something. If I write something today, 4 days later, I'm not sure if I can read my own handwriting, right? So how is it that a computer program is able to actually read the addresses written by anybody, anywhere? Well, one thing that is going for us is that when somebody drops an envelope in the mailbox, the intent of the writer is that it should reach a destination. So they leave enough clues and legibility over there in the writing so that whoever is carrying the mail will actually take it to the destination. The technology today is such that no human being needs to lay eyes on the address. Right? It's completely read by a program. A camera takes pictures of the address, the front face of the envelope, at a fantastic speed, like something like 13 mail pieces a second. The images are captured, recognized as to what the destination is, and a corresponding barcode is sprayed, and then it essentially is delivered to the destination. So the mail carrier might, just before dropping it into your box, might check if it's the same or is it your neighbor's address, but that's it. Everything else is done by a program, and we pioneered that technology 30 years back, at least made the industry to believe that this is possible. Okay, so how did we do this? There are more than 250 million destination points in the United States, right? I have an address, you have an address, there's companies and so on. So every place where a mail can potentially, be delivered is a destination point. 250 million. So if you look at it as a pattern recognition problem, I have an image of an address, and I have to tell you which of those 250 million is the correct destination for that image. And we use the age-old divide and conquer approach. So what we do is we first look at the zip code, right? So when you look at the zip code, there are 5 digits, and each digit is one of 0 to 9. So it's a 10-class problem. So we first try to get the zip code, then we try and look at the street number. So there is processing involved in locating where the zip code is, locating where the street number is, and once you have those numerals recognized, you look up a postal directory. And this is the power of the context, is it turns out that if you have the zip code and the street number, there are only about 20, 25 street names possible with that combination on average. It could be as small as 1, it could be as high as 150 or 200, but most of the time it's in the range of 20 or 25 street names. So the pattern recognition problem now is reduced to locating the street name image snippet and telling us which of those 20 or 25 street names it is. So once I have the street name, then there is a 4-digit add-on that corresponds to the street number on that street. Given the zip code, you get the 9-digit PIN or the 11-digit if you add the 2 digits of the street number. So that's how this whole thing works. And we were able to come up with this algorithm and do handwriting recognition. But as you can see, in this case, the lexicon is going to be very dynamic, right? That means that every time you change the street number or the zip code, a different set of 20, 25, 15 street names are going to show up. So your recognizer has to essentially match the snippet with a dynamically changing lexicon. Okay, so that's how we define the handwriting recognition problem. This is quite different from the static lexicons, for example, in the bank check application. When you have a bank check, the total, so the legal amount is what you spell out, and the courtesy amount are the numerals in the box. So whenever there is a disagreement, whenever there is a dispute, maybe this is something that everybody should know, what is actually written is what is valid, not the numerals, okay? So the numerals are only a courtesy. So if you write on the legal amount $10,000, and in the box you write only 100, it's the 10,000 that is going to prevail. But if you look at the legal amount, what are the total number of words that can possibly show up over there? Well, if you look at 1, 2, 3, and so on, and unless there are some millionaires and billionaires, it's usually around 35 or 40 names, and that's static. No matter whose check it is, it's always that same lexicon you have to match against. And that's, in some sense, an easier problem than what we are looking at in the postal addresses. Because in the country, there are hundreds of thousands of different street names, and at any given time, I have a subset of that list that I have to match against. So the static lexicon can work in different applications. For example, it could be in the medical field where you're looking at different prescription medicines. You could be in the medical field perhaps looking at different diseases from a database and so on. So the sizes can vary, but you have a static fixed lexicon of some reasonable size. Now, let me show you how we actually used the power of the lexicon to make that matching between the street names and the directory, whatever the directory is saying is the set of street names and the snippet of the street name image. So let us say I have a lexicon and I have shown you 5 words in the column over there, simple words. This is a made-up example. And then you have an image which is shown over there in the white patch. So what we do is we first find out all the concavity features in that snippet image. And you will see that there are about 9 places where you can potentially break the contour and say that this is a potential break between 2 different characters. Okay? So in this case, if we all know it is W-O-R-D, which has only 4 letters, but you have about 10 segmentation points, right? So now the question is, how do I fit those lexicon entries with this image? So since I know the lexicon, I say, okay, what are the starting letters in all these lexicon entries? So there are only a few, right? Some of them are W and some other few characters. So the only question now I'm asking is, the very first part of that snippet image, how well does it match with the W? And I can come up with some heuristics which say that no character can be divided into more than 4 parts, okay? So now I can take the very first part, the 1 and 2, 1, 2 and 3, 1, 2, 3 and 4 together, match it against every potential first character from the lexicon. And then I move on like that. So that generates a graph where you can see the 9 nodes, those are the segmentation points, and the arcs essentially tell you how much of that snippet image I'm going to consider now. And you can see no arc is jumping more than 4 parts. And you do the matching. And so this way, we are able to take advantage of the power of the lexicon. So if you give me only 20 street names, I can do this same methodology, and I can then be more accurate, right? So now, essentially, I'm going to find the best path in that graph which goes through all the nodes. That means I'm going to cover every image piece of that snippet, and I have to match the letters, okay? So now you can see how from 250 million options, I have brought it down into a simple problem as I just described. Now, let me take this a little bit further. So that is one approach. Another approach is I take the handwritten word image, and I simply come up with a profile, which means I just take its outline contour, okay? So in that white patch over there, you can see that there is an outline contour, and I try to count how many ascenders and descenders are there in which position. Obviously, I don't know what the characters are, and as our handwriting will tell you, we have only some of the letters which are legible, and the rest is a scribble, right? And based on the context, we pick up the word. So if I can just find out where the ascenders and descenders are, so ascender is something which goes above the middle zone, and descender something going below, and roughly its position, whether it's in the beginning, the middle, or in the end, then I can come up with some kind of a feature graph coming out of a profile, right? And then if I tell me which US city that profile corresponds to, you might find it not that easy unless I gave you the choices. But once I give you the choices, and the choices are up there on the screen, you say, well, it cannot be Boston because there is nothing coming down as a descender, and it cannot be Amherst, because the ascenders are not matching. And then, well, you say, okay, it's Buffalo. This is very much like a multiple choice question that we give to our students in the exams. And I used to love multiple choice questions in exams, because what it does is it allows you to guess, right? So if you have a sense, if you have some sense of where the answer should be, you can eliminate some of the choices and get lucky and get as many marks as the top student in the class, right? So we all love multiple choice questions, and that's exactly what we are doing over here. Is I really don't know or care as to what letters are there in that image snippet. All that I'm saying is there are a few ascenders and descenders, and if I can look at the lexicon, I can go back and forth, and I'll give you the good answer. And just like in our exams with students, it becomes really tricky once you put none of the above. Then you scratch your head saying, should I guess or shouldn't I guess? And the same thing holds over here, right? So we should be able to, in the postal automation case, be able to tell that I'm not very confident about the answer. I would rather not have a barcode sprayed. Let a human operator look at it and give the answer. So that's what the multiple choice question paradigm is. So now you can take it further, and you can see that if you give me a word image, and I only have ascenders and descenders, so I have a string of those features, and if you tell me the choices, I will tell you what the correct choice is. So this is what we call interactive features. That means you're allowed to go back and forth between the question and the choices, which is what we would do if we were given a multiple choice exam question. We will look at the answers and go back and see if it fits, does it make sense, should I eliminate some choices, and so on. So that's exactly what we are doing over here. Let me show you how this is taken forward with numerals. So here what we do is, let us say we have numerals 0 to 9, and if you look at those 3 examples over there, 3, 5, and 7, you will notice that 3 and 5 are exactly the same for the lower part, and 5 and 7 are exactly the same on the upper part, right? So when I'm looking at distinguishing between a couple of numerals, I should know where to focus, right? So in this multiple choice, I have 0 to 9 as my choices. I look at the image, and I then decide what features I should look at based on which choices are competing. So in this case, we come up with 9 features, a binary vector. That means I look at the right side image, which is the number 3 and its contour. I will divide it into 5 parts, the 4 corners, and then 1 block in the center. And I will ask the simple question, take the contour profile and make straight lines between the curvatures, okay? So you approximate it with just line segments turning sharply at corners. Then you ask, how many of them are left diagonal, how many of them are right diagonal, how many are vertical and horizontal? 4 features. If it's above a number, it's a 1, otherwise a 0. And then you say, how many such segments are there in each of those 5 blocks? Above a number, 1, otherwise a 0. So that 5 plus 4, 9 gives you what is called a binary vector. Okay? So now what we can do is, I'm just trying to show you how we actually take it forward, in the handwriting recognition. This is a variation of what we call the A-star algorithm. Is I should know which part of the image I should dig deeper into and find finer features to distinguish different pairs of numbers. So we use something like a tree where you divide it into 4 parts and each image, and then you decide which of those 4 parts, the 4 corner blocks, you are going to dig deeper into. And so that's how you go into the tree, and then you come up with a vector. Each time it's a 9-bit vector, and so that's what is going to be matched against a lookup table. So the point I'm trying to convey over here is we are using the power of the lexicon, the power of the choices, and making it an interactive process, and that's what pattern recognition is. And this is, by the way, all old school, old style artificial intelligence. This is what in the 90s gave us the success that we are very proud of. So if you look at the performance numbers, you will see that when the lexicons are small, obviously you do very well. And as the lexicon size increases, you don't do that well. Okay? So essentially, word recognition and handwriting recognition in very narrow applications is a tractable problem, because we can use that power that the lexicon, which is captured, the context is captured in the lexicon is the vocabulary, and that's how you move forward. So here is a nice chart for everybody to take home. This shows how AI has evolved. So if you look at from the late 80s, early 90s, optical character recognition, which is the umbrella field under which handwriting recognition would come under, whatever I have described comes under optical character recognition. Essentially, it means that you take an image of something that is written and recognize it automatically. So you can look at that curve, which is essentially moving up the red line from the left, and it slowly crosses the 0 line. The 0 line is human performance. Okay? So in the 90s, the performance was near 0 before we came into the picture, and we solved the postal automation handwritten recognition problem. And now you can see in today, it's better than human performance. So machines can actually read handwritten addresses better than you and I can, because it can bring in so much more knowledge from examples, because it has seen so many examples. So you can see that slow rise of our field. Then there is the green curve, which is representing speech recognition. So go back to the 90s, and some of you probably will remember, AT&T, you call the operators, they wanted to have automation, and it was such an annoying thing that you dial and some, program picks up from the other side, and you keep expecting it to know what you're saying, and it won't work. Nevertheless, that's where speech recognition, the main application started. And you can see now the green line also has crossed the human performance. In narrow applications, like in your fancy cars today, you can talk to Alexa or Siri or so on, and it does recognize and does a very good job of understanding what you're saying. Of course, it is trained to perhaps your voice. It knows that you're looking for people. It's in your address book and so on. So the context is brought in, which narrows the application, and you have success. Then if you move forward, you look at the other 2 lines. The red line is the image recognition, which coincides with the ImageNet that was released by Fei-Fei Li from Stanford, which essentially allowed lot of the deep learning that started with having large data sets. And then language comprehension, again, almost vertical line, which corresponds to ChatGPT and generative AI. But all of these, in narrow applications, are doing very well and in fact outperforming humans. But if you give it some general purpose task, for example, if I drop my phone over here, unless somebody actually told this AI program that when you drop a phone, there will be a thud and then the screen will break unless you have a screensaver and so on, it doesn't know, right? But that's common sense for you and me. So it's still ways away from actually having general purpose AI, and lots of people are working on it. So talking more about the power of context, look at these two handwritten images that you're seeing. If I don't give ChatGPT the context, on the left side, you can see it returns the answer saying, I don't know what is written over here. I have no clue, okay? And then for that same handwriting, you actually give the prompt which actually was responded to by that writing. And once it knows the context of the prompt, it gets pretty much everything correctly. So that is the power of lexicons and the power of context. So like multiple choice questions that you and I like, the machine loves it, okay? So once you give more context to the machine, it can do extremely well. So where does that take us? So if all of you, if you remember, and still, on some of the websites, when you go for a service, you see these squiggly characters. It was very common a few years back, but now it only says, I'm not a robot, click here. And you click and it, so it is actually picking up other kinds of features like your IP address and browser and how your mouse is moving and those kinds of things. But even once in a while, even now, you will see that those are squiggly characters which come up and say, prove to the machine that you are a human being, right? That you're not a robot. And so how was that test designed? It's called CAPTCHA, which is essentially a reverse Turing test. What you want to do is you want to find the sweet spot where humans can recognize effortlessly, but machines cannot recognize. Okay, so if you look at the top chart over there, there are two curves. So there are images or tasks where both humans and machines are good. There are tasks where neither of them is good. We are looking for the sweet spot where humans outperform machines. So finding that sweet spot has now become non-trivial because machines are getting better every day, okay? So the CAPTCHAs that you and I were hoping, saying, human superiority, right? I can type in that particular squiggly word is CHAIN or whatever that is, and the machines cannot do it, okay? So that's the distinction that was there. But since this is like an AI race, the AI is getting better and better. And today we did some experiments where many of these CAPTCHAs, those squiggly words, are actually being recognized by machines. That means if you go to Twitter or any of those troll places, there are probably bots getting in. They're not human beings over there because they can read those squiggly words just as well as you and me. Then in the right bottom, you can see there are two CAPTCHAs. This was called the reCAPTCHA program, which was very clever. I believe it came from CMU, where they would give you two words. So one word was the test for you and me to tell that we are humans. The other one was a data collection effort for them. They were getting free truthing done, right? So you type in both the words, they know, okay, this person is actually a human and this image is these characters. And that was pretty clever. And so that was being done. So where does that take us? We said, let us look at what these CAPTCHAs will do today. Okay? So we picked up some CAPTCHAs from actual real websites. You can see the URLs in the bottom. And we said, let's feed, these are real CAPTCHAs from these sites. And we said, let's just drop it in Google Document AI, Azure AI, Amazon GPT-4. And look at that, about 40% can be recognized. What it means is almost 1 in 2 the bot can actually get into that service. So they are ineffective. We would like those CAPTCHAs to be such that only maybe 1 or 2% recognition by machines. That means only 1 in 100 will actually get in, right? So something needs to be done. Okay, so I have more experiments. So I said, well, maybe those squiggly ones, the reason we were doing very well and machines were not able to do well before was because those were nonsensical words. There was no vocabulary, there was no lexicon to draw the context and do that multiple choice question that we discussed before, right? Because they're nonsensical, you can have very, very, very large number of nonsensical words, and the machine was failing. But then, lo and behold, now the AI programs are very good, even if they are nonsensical words, they're getting 1 in 2. So we said maybe humans still have superiority if those are handwritten characters. Maybe there is something in our brains which is allowing us to do something very special. So what we did was, we picked up some handwritten characters, and we said, let's look at what happens if we train the OCR. So the way we generated these captures, on the right top, you will see whole bunch of handwritten characters put together. Okay? And so we developed a program where we got these handwritten characters from the NIST database, MNIST database, which is available publicly, and we put them through several transforms, right? Rotate them, take their skew, take their affine transforms, take out some pixels, remove some, add some noise, and so on. So there are different transformations we did randomly, and then created those strings on the top. And we said, let's see if the computer programs today can actually recognize this. And you can see that the OCR, TR-OCR, which is open source, when trained, can get 40% of these as well. And ChatGPT, because it's not able to train on these, is getting only about 10 to 15%. Okay? So there is some hope still, but I don't know for how long, right? And then, just to be a little cute, I said, okay, forget handwritten captchas. What if I pick some prescriptions from doctor's handwriting? Now, that should be challenging, right? There you need something beyond superhuman intelligence. So that's the right bottom corner. And even there, you can see that the OCR, when it is trained on these, is getting 86%. And even ChatGPT-4 is getting about 60%. So the race is still on. We are still trying to find areas where humans can assert their superiority. Remember, once the application constraints are given, machines are getting very good. So here is another example I looked at, and I said, let's look at children's handwriting. So you can look, the adult handwriting is on the left side, the child's handwriting is on the right side, and you can see the performance numbers, okay? So here, if you see that the performance numbers, if you look at word error rate, so adults, it's doing pretty good, about 92, 93%, and but in children's handwriting, it's not doing that well. There is another clue over here, because I'm trying, please keep in mind, to find that sweet spot where humans can do things effortlessly and machines cannot. And the race is on, and the machine AI programs are getting better and faster day by day. So I said, okay, now let's maybe look at children's handwriting. What is happening? And here is the clue. Because of the overdose, in quotes, of the context, what it does is it simply goes and starts correcting things. Okay? Now this is also quite annoying. Many of us on phones, we know that that autocorrect is a nuisance. Right? You're trying to type something and it wants to force something else, and it's quite embarrassing sometimes as to the kinds of words it picks. But that's what is happening, right? Because ChatGPT and all these large language model AI programs are going to fit the context. So if you look at the right child's image, you will see that some of the words which were not actually written, there were spelling errors and so on, they are getting corrected, okay? Sometimes correctly, sometimes in a hallucinating way. So we thought, wow, this is a very interesting place where we can find that sweet spot. So we said, let's collect children's handwriting, and children's handwriting has all kinds of challenges. The handwriting is not very neat and tidy, and it will have spelling errors, and it will be crowded sometimes, and it will be sparse sometimes. let us study children's handwriting. So here, you can see examples, and you will see how, when you give it to ChatGPT, it goes and corrects. It does not preserve whether it's uppercase and lowercase. It wants to correct. It wants to correct the spelling errors. It wants to correct the grammar. It wants to do all of that. And for all those who work in deep learning and neural nets, where there isn't that much transparency offered by the box of neural nets, you don't know how to undo these things. It's almost as difficult as undoing hallucination, from the current LLM programs. So how do you do this, and can I find that sweet spot is the question that we are asking. So here, and this is even more interesting, if you look at this example now, you will see that not only can it correct, it actually fills in words that are not there. Very much like the hallucination, but not that bad. I mean, it's still within the context. It's not way off, but it is doing more than what we are asking it to do. Okay? So I will skip this. So the point being made is that it is still making errors. And sometimes the use of context by these programs is quite amazing. Look at that picture on the right side. I bet all of us will struggle to read what the kid has written over there. And this ChatGPT program, with no prior training, you drop that image, it knows where to put the picture aside, and it can actually read and transcribe it perfectly. Okay? So it knows, how to use the context once again. There are more examples over here, and you will see something very similar, where it is able to tell what is written, and you and I will struggle to read what the child has written. So we said, well, maybe this is a lost cause. Trying to do better than the machines with today's LLMs is, you might claim success for a few days, weeks, or months, but as soon as the machine gets hold of all the training examples, it can use the context and solve it and do much better. So we said, well, we are researchers, right? Sometimes we are looking for problems. We already have a solution. We solved the postal automation. I have the hammer, give me the nail. No, I'm just kidding. So we said, well, let's look at children's handwriting with dyslexia. That's a huge problem for millions of children. And there is a large population percentage who suffer from dyslexia. And maybe that is a place where using the context is not a good thing. I actually want to know what errors my child is making. Please don't correct it. Please tell me, where are they flipping the characters? Where are they making spelling errors? Where are they writing things out of context? I want to know all of that. So maybe the human intelligence calling in this field of OCR is dyslexia and dysgraphia. So we said, okay, let's look at this problem. And this is where we go back to the NSF AI Institute. So we at University at Buffalo have won one of these $20 million awards, which is like the grand prize in AI and NSF. We are one of 25 institutes, actually 27, 2 more were awarded just recently, that have been awarded over the last few years. And UB, Buffalo, is leading, and I'm the PI of this with a consortium of universities from the West Coast, Stanford, University of Washington, on the East Coast, Cornell, and Georgia Tech, and we have Illinois, and so many partners. And the idea is, can we develop artificial intelligence tools to help children who have speech and language challenges? And all of us know in our lives that we have family or friends of friends who have kids who are facing this challenge. So maybe artificial intelligence can actually be put to the true public good, right? No apprehensions here. This is purely for public good. So what we did was, we looked at studies which said of the 13 different disabilities that the US government identifies, if you look at speech and language, and where it affects learning, there are about 3.4 million children today, these are official figures, So probably the number is higher, who need some kind of assistance so that they are not left behind, right? Like everything else in the healthcare field, earlier you detect, earlier the intervention is, the better the chances of overcoming that challenge, right? So we framed the problem as follows. We said there are 3.4 million children. How many speech language pathologists are there in the country? Turns out there are just about 60,000. So if you do some quick math, you will understand that there aren't enough speech language pathologists. These are people who sit with the children and help them overcome their difficulties, right? So there aren't enough so that a kid can get the nuanced, personal, customized attention. So what is happening in public schools is maybe there is 1 hour a week in a group setting where the SLP or the speech language pathologist can help the children. Can AI help? So that's the question we are addressing in our AI Institute. And it has two parts, two sets of tools. One is called screening, means all children should have access, all parents, all caregivers, all guardians, they should have access to these AI tools so that they can screen the children and figure out who needs help. And once you identify those children, then you can come up with what we call the AI orchestrator. That means develop tools to intervene and help them overcome those challenges. So if you look at dysgraphia, actually when we talk about handwriting, most of the time it is dysgraphia if you want to be technical. And dyslexia is a more general term which includes some handwriting issues, but is also about speech and grammar and correctness of language and so on. So we look at all of these, and I'll give you some examples quickly. So there are 13 different ways in which you can, these are the markers. So if I look at a child's handwriting, and if I can pick up these 13, then I know that the kid is having some problems with dyslexia, dysgraphia, or both. So let me go back. So you can see what kind of problems they are. They are usually either spelling errors, word choice errors, flipping of characters, mirrors of characters, vocabulary problem, they cannot organize their thoughts, and so on. So a teacher needs to actually look at all of these, and let's go back to what these big LLM AI programs are doing. When you feed them these images, they are not going to tell you where the error is. They are not going to tell you what the error is. They'll just correct it, right? So I think we have our sweet spot. We are going to be doing handwriting recognition to find out where the children are making errors, what kind of errors, so that we can do the screening and we can do also the intervention. So I'll just flip through some of these so that I can be on time. So you can see there are various errors in these handwriting. There are all bunch of examples. And this is some of the work that we are also collaborating with Illinois and also with Nevada, Reno. Okay, so all these different examples of handwriting. And these are the 13 different disabilities, many of them which are affected by speech language. So now we said, well, there are some pathways, cognitive pathways. Clearly, this is a hypothesis where handwriting and speech come together because both are about language. So is it the case that if a kid is struggling with speech, is also struggling with handwriting and vice versa? Or is there a big overlap? So these are the kinds of studies that we are carrying out. So we are going to be looking at speech, writing, and nonverbal cues as well. Because if you look at the entire autism spectrum, it could be behavior, right? I mean, is the kid isolated all the time, talking to themselves, keeping to themselves? How are they interacting in a group? So all of those things need to be considered in what we are developing in our AI program. So I'm going to just look at a few of these things. So for example, we want to look at how does a speech language pathologist do the screening, and can we do automation of that? So it's called structural priming. So you ask the kid to complete different simple sentences. You tell the subject and the verb, and if there's a pattern to the sentence, and the kid is supposed to repeat it in various scenarios of increasing difficulty. and then you look at how many times they're getting it correct. So if an AI screener could be in action without any person around, we could have that small robot over there, which is the logo of our AI institute, and it could be essentially the kid could be watching on a television, and the robot could essentially help in figuring out if the child is having any issues. So here it says the baby is sleeping, and then the question asked is, Kitty is sleeping, then there's what is happening over here. So the kid is supposed to say, Kitty is sleeping, or something very simple based on this, and you figure out whether the child is having problems or not. And we can do the same thing in group settings. And this is also something where we are working on identifying who is the speaker, is the child participating in conversations, in group discussions, or not, right? And are they understanding? And so the entire behavior spectrum is essentially going to be looked at, and alongside with handwriting and speech, we're going to be developing these tools. So when you look at speech, so when we talked about handwriting recognition, note that we said that children's handwriting, the AI programs are not doing very well, okay? So is the same thing true with speech? And indeed, yes. And we can try this out, right? I mean, if the children are speaking, Alexa or your Siri doesn't do that well. And we have done some tests, and we see that the latest state-of-the-art speech recognizers, when it comes to children's handwriting, are not performing very well. And one of the reasons is there are no data sets, and there are issues with getting, because this is sensitive data, this is children's data, there have to be IRP and protocols and consents and all of those things. So there aren't that many data sets available, and AI today is all about data, okay? So we are trying to address some of these issues as well by not just capturing the speech transcription, but also the body language and the behavior. Are they stuttering? Are there gaps? Are they repeating the words? Are they emphasizing at the right places? Is there empathy? Is there emotion? All those things are being transcribed so that we can holistically understand how the child is performing. And we are taking all of this from scientific papers, okay? So standard papers in learning theory on, what are the metrics that tell you whether or not a child, because please keep in mind, sometimes what happens is children are coming from different cultural backgrounds, and English may not be their first language. So they might be hesitating and might be having difficulties. That does not mean that they have a speech language problem, right? And also there are ways in which things are spoken in different cultures, which also needs to be taken into account. So before I forget, one point I want to make here is that this screener is also a great way of addressing equity issues, because chances are that in certain geographical areas, there are going to be fewer speech language pathologists, okay? Poorer areas, remote locations. So you absolutely need some automated tool. So then we essentially are looking at, can we find the cognitive pathways and connections between speech and handwriting? And there has been some discussion on this, but no in-depth study. And some of my students are actually looking and trying to explore, what is that connection? And in order to do that, we have developed a tool which helps on a pad, where you can write, the electronic pad where you can write. So we are using it in schools to see if we can teach them how to construct words, right? And what takes construction of words and automatic recognition and correction, because it's all going to be handwriting. And then some other advances, and these are some examples of what we are doing with these, and I will not go into it just so that I can be on time. We are also looking at learning science metrics. So automaticity, as I was just describing, all previous studies are talking about how many words are they getting correct. The percentage of grammatical correct utterances is a metric. So we are looking at automaticity, which means how fluently or how smoothly do they say a word so that it can be language neutral and cultural background neutral. And then we are going to actually put it in schools. We are going to have these screeners and orchestrators in schools. What is today a very ad hoc process is going to be streamlined with our AI tools. And let me show you some interventions over here. And I don't know if I should risk playing a video right in the middle of the talk, but maybe why not? Let's see. So I'm going to show you how a speech-language pathologist interacts with one of the children who is having difficulties, and then talk about what we have done using AI. And there are a whole bunch of ways in which they work with the kid. They might just have them watch how the mouth is shaped when they're pronouncing different words. They might be having difficulty, for example, s and sh. Maybe they can't make those two different sounds and they can't hear it properly. How do you help such kids, okay? Can you show them on an iPad, the different grammatical ways of pronunciation? So the sound the, where does it come and where does it come as th? Because there are those ambiguities. So we need to work with these kids, and we have come up with some tools. So here you can see on an iPad, it tells you, how the kid can learn, the sounds th, in different contexts. Let me just jump to this, and I will try and keep my fingers crossed that it will work without an issue.
So, show. Good job. So. Ooh, which one did that sound like? It did, didn't it? Let's see if we can make this one sound like the quiet lady. Show. Okay, good try.
What you're seeing is the pathologist is showing some flashcards that are those pictures.
Hang on, oh, come back a minute. I couldn't hear the ending. Book.
I'm going to forward here. It worked. I don't want to play the whole video, but a pathologist who's on our team said, usually these pathologists will go to different schools and they carry a pack of cards. And if they're trying to help the kid know the difference between sir and sh, usually they will come up with contrastive words where only those sounds are different and the rest of the word is the same. And then they'll show the picture of that word so that the kid can relate, and that's one way of teaching. So you can imagine the grunt work in carrying all these cards, figuring out which pairs of cards they should use, and whether or not they have those cards. And what if it is culturally sensitive for certain kids? Can you change the cards? So clearly now we have with AI a solution which is working very well. So what we do is we come up with methods of generating pairs of words on the fly. So you tell me which sounds there are issues, and you can, based on the placement of the sound, the voicing, the air, the breathing of the sound, you can come up with pairs of words on the fly using AI programs, and then generate those pictures on the fly, not picking from a database, on the fly. And so on an iPad, you can show the kid, and if you don't like a pair, you change the card. I have a live demo. I can show it to those who are interested right at the end. But let me just move on and show you a screenshot of what we do. We go to the cloud through ChatGPT, figure out what pairs of words, and then use diffusion models to create those, and then show it over there. As you can see, the two pictures are shown. So here, let me show you. So here is an example, and what I'm showing is leak and peak. So you can see only the beginning part is different, and I can keep generating those pictures, and it's not easy for you and me to come up with these pictures. The AI programs are fantastic, and they can tell bowl and bow, how do you say rake and cake, and these are all being generated on the fly. I can show you a live demo. Okay, I'm going to wrap up quickly. Another part that we are doing here is, remember the children apparently, they have to watch how the mouth is shaped in order to get the sound correctly. And you have to do it over and over and over again. So if a program can do it, all the better. Also, apparently, a child, if it is looking at its own picture, making those correct mouth formations is very likely to connect. So now here is a good use of the deepfake technology. We can actually create the kid's own picture, own face, do the mouth formation correctly for those words, and the kid watches and learns because it can be done over and over again. That's what this demo will show, but I'll skip it. And then this is the final example, where we are also looking at reading material for kids, right? So if the kid is falling behind, the kid is in 6th grade, struggling with 4th grade reading material. So can I take the same passage and dilute it so that it becomes 4th grade ready, and or take it to the 10th grade? So can I move it on a scale, the same passage and contents? Well, you might say, ChatGPT, this should be trivial, right? But here is the trick. How do we know that the content is not being altered? How do we know that the semantics is not changing? So we have to keep the semantics the same, but the way the language is presented has to change on a scale. So we can do this. There are standard theories on how do you test the reading level of an English passage, and what grade is it appropriate for. So doing that, we can see Wall Street Journal, Time Magazine, and Simple Storybooks, they have different reading level grades, and we can move paragraphs from one level to the other because it is tied to the number of syllables in a word and words in a sentence. And the trick of how do we know it is doing it correctly is, this is an interesting thing. We pick up passages where there is one correct answer. So like a simple math problem. So now, doesn't matter whether you made it more difficult to read or less, the answer should come back the same. Okay, so then we know that the semantics did not change. So this is a project in collaboration also with Cornell. And this is the house we are building for AI for public good to help children. There are a whole bunch of aspects. I tried to move quickly, given that we don't have that much time. And we are going to validate this in schools so that human speech-language pathologists, our programs, and we'll do a comparison to see how effective we have been. But always please keep in mind the human being is going to be in the loop. Both for the diagnosis, we are not qualified, we don't have the license, the programs are not allowed to diagnose somebody as having a problem or not. The human being will be in the loop, but the grunt work will all be done by these tools. We have an AI institute. I welcome all those folks who want to come and check out. We have built it in a child-friendly way. You can see the nice colors over there. We have a sandbox, where we are bringing in kids from local schools. That's the picture of all my PhD students so far. I'm just shy of 50, so you can see, that placeholder is there, but soon maybe. All that said, thank you very much.
Thank you so much, Vadio. So we have time for questions.
There.
Thank you very much. That was quite interesting. I had a question about the speech pathology. How do you deal with accents? Especially because if children are, if the parents are trying to help, not just at school but at home, how their mouth is making the sound and that sort of thing.
So excellent point. So we are hoping, just like in the reading, we can move it on a scale. With AI, we are hoping that accents and culturally relevant things, so somebody comes from a background, they should be able to relate to the passages and the kinds of things that are being talked about. So how do you change the accent? How do you change the content? Everything using AI. So those are all underway, but a very good point. And we want to be very sensitive because, as you know, in certain places, it's very easy. There are certain words which are said in different ways. And that does not mean that the kid is having a speech-language challenge.
One of the things that, as you know, a lot of schools are banning the use of cell phones and other things. And where there is technology in the classroom, I think oftentimes the human has to compete for supremacy of the kid's attention span over the piece of technology. Is design of
educational stuff, in your lab going forward, sort of looking at some of these considerations? And do you see a new generation of how these things are designed that not only puts the human in the loop, but helps the students' attention focus on the human in the room?
Excellent question again. I think all of us know that if I just took a 6-hour course online on a particular topic, I'm telling you it is so difficult for me to keep my engagement and attention on something that is just being told to me on a computer, right? On the other hand, I could easily sit through a 1-hour lecture if it is interesting and be engaged. So as it is, just giving technology and expecting children, to all learn from that is not going to work. So there has to be pedagogical ways of engaging them without technology, but at the same time cannot ignore the technology too, right? Because the real world is full of technology. So that balance is going to be key as to how these are designed, how the teachers are going to be effective in a classroom. So, but point is a very good one.
We have time for one more.
Thanks, Ramandeep. Hi, so I work at the Lucy Institute, but I also wanted to throw out there, as far as the speech therapy, I remember as a kid, I was in speech therapy for 5 years. They were pretty sure I was not gonna be able to speak things, but once the speech pathologist actually had the voice recorder and it was constantly playing back your own voice to you, like that was the huge changing point, where suddenly I could pronounce things. I still don't pronounce things very well anymore, but excuse me. I was wondering, I know it's difficult to do, especially it's a problem of memory and how much the AI can maintain what you're holding, and then also you can take that and go places with it, but future things for the speech therapy, and I wasn't sure like if you guys had already worked in being able to play back voices to yourself, being able to, for the child to look and say, okay, if I'm playing back this one versus this other one where the AI told me this was wrong, can I hear the difference now?
Yeah, no, excellent. So that's exactly where that other piece where I was saying that the child looks at itself, saying it correctly, and these things can be incorporated, saying, look, this was the incorrect way, this is the correct way, and then repeating it again and again. One of those papers that I just flashed over saying evidence-based methods actually says in the title, bombardment. What it means is keep repeating with the child again and again and again and again, the correct way, and then they, eventually do pick up and get it. So, yeah. So there is so much scope here, and what I love about this is wherever we talk about this particular project, people are very happy, because otherwise you read in the news every day, oh my God, AI is going to take over and human race will be extinct. Okay, so there is no apprehension here. We can feel good that AI can actually do good to our children.
On that note, thank you so much, Peter.
Thank you.
Thank you so much. Well, again, thank you, and what a way to kick off our annual celebration awards night with such an amazing story about how AI can be used for good. How the journey from, as you mentioned, all of AI is the limitations come from data, how the journey from data to society, and AI is spank in the middle of how we can begin to make a difference. And again, this is excellent, excellent work venue, so thank you. And I'm still wondering how you manage to be curious about research and lead big, large grants while maintaining a $450 million research enterprise when you were at University of Buffalo. So congratulations. And something I didn't share about him earlier, he is also a poet. He's written poetry in Hindi or Sanskrit, and he's waiting for the Prime Minister of India to write a preface, and then that shall be published. So alongside all of this, this is another of his skills, and hope, so we wish you luck for your poetry book as well, and I'll hand it over to Matt to convene the next steps for the day. Thank you again.
Thank you, Natasha. Yeah, so we just have a couple of reminders as we are going to move now upstairs to the poster and reception. And anyone that came in a little bit late, the bribe for getting back in the elevators and going upstairs is that's where the cocktail hour is. So please do follow us up there. There's 2 sets of elevators, one on either side. You can go to either one. And I will say that we need to prepare the space for dinner. So if conversations could be moved upstairs, that would be great. And if you haven't gotten your name badge yet, please grab it on your way. The registration desk is over that way. Otherwise, we'll reconvene up there in just a little bit and then come back down at 6:30. Thank you very much.
Hey, Jonathan. You're the only one who waved back at me. Hence, from today on, you're my favorite student. And you were the second one. Jason, you're my favorite colleague. Ali, you're my favorite software engineer. Soren, you're my favorite postdoc. Anyone else? All the students are gone. Student is gone now. You were just too engrossed in wine. Yeah, take a lesson from Jonathan. And he just started this semester. Hi, friends. Thank you again for joining us for our annual awards evening. And as Matt said, that I didn't promise I'll be brief, but he pretended that I promised. And Katie has prepared something that says Nitesh's introduction, 5 to 10 minutes maximum. So what does it mean, 5 to 10 minutes? 5 or 10, I don't know, right? End by 7:55 p.m., so I gotta get out of here by 7:55. But again, thank you so much. But before, Father Grove, thank you so much for your beautiful, beautiful prayer with us today and your presence and your blessing. So thank you so much. Please, everyone, let's thank Father Grove. And today evening is truly a celebration of all of us, all of you, and all the amazing work that we have done over the past 1 year, and the achievements we have had collectively. And I feel that I have the most amazing job. Why? Because I don't do anything. I just get to stand here and talk. This is the best job, right? To be a spokesperson of all of you and then have my favorite PhD student, favorite colleague, favorite software engineer, favorite postdoc. My friend Josefina, you are my favorite colleague, but right now Jason just happened to be before. But I'm told I have some slides, because slide 1 is something here, Katie. All right, thank you. So this is the mission and vision of our institute, and we sort of went through a journey about a year and a half or so ago. Was it 23 or 22? Katie? Strategic planning, 23. So in spring 20, for 6 months with David Bailey and his team, and if you haven't worked with that team, I encourage you to, because they're brilliant. They're amazing in how they get you to think about what your goal, plan, and mission and vision should be. And we went through that exercise, and we are really, that was amazingly informative about who we are, where our challenges, where our gaps, and who we want to be. And what was very clear to us is that the name, the Lucy Family Institute for Data and Society, and first of all, the name Lucy Family Institute comes from the generosity of Bob and Sarah Lumpkins. As if you haven't met that amazing couple, their gift to endow this institute, and it's endowed in the name of their granddaughter and the maiden name of the grandmother who immigrated from Ireland. So it is that legacy, and we have that obligation and responsibility to make sure that we are doing great by their gift. So, and the data and society, as to what we try to do with data, responsible AI and society, as long as we are guided by the mission of our amazing university, we'll do well. And that's what is in our mission, is that we have to be guided by our university, and everything else that follows will be good. So if we can just make that pact amongst us with our university, we are in a great shape. And we want to build up data science and AI innovations, and we want to be distinct. We will be distinct. We are distinct. I should have a bit more humility being at Notre Dame, but we are distinct, right? In being an amazing place. Father Grove has blessed his words. So we are distinct because we truly are trying to take on some of the wicked problems, challenges that the society faces, that even what a strategic framework calls us out to do. And we are addressing them as what can data science AI do to address us. We spent a couple of days working with an amazing group of colleagues from the country and beyond on health equity challenges. Some of you are still here with us for dinner. And it required that collective thought. It required that collective wisdom. And that's what we want to be. And to have that collective wisdom, we have to be adventurous. We have to be adventurously collaborative. Because collaboration is not easy. Collaboration dies when one thing becomes subservient to the other. Collaboration is adventurous courageous when we say, hey, we don't know what to do, but we will figure it out. And we know that once that's set in, that motion is set, then we will have an outcome that's going to be really impressive. I see that, I think they're timing me. They already moved to the second slide. I haven't finished the vision as yet. Right? But the vision, and we want to be, I believe in it so much. And Walia just said that this is like, Lucy's like my third baby of the family or something. But it truly is, and Lucy, the vision of us is to be that place where when the world thinks about data science, AI, and its impact on society, that this place brought together amazing scholars, amazing scientists, amazing students, the posters that you all had today, and built bridges that Father Bob said in his inaugural address, created a community of learners that Father Bob said in his inaugural address, inspired pathways to Notre Dame that also he said in his inaugural address. That's the beacon we want to be. That's what we aspire to be. And how we are truly getting there is, as we have a number of initiatives that we have launched from our education, our ITRED scholars here. ITRED scholars, please get up, stand up. Please, these are amazing undergraduate kids in Sagana. Please stand up with them for mentoring them. All the ITRED's undergraduate scholars, And these, students are an amazing example of what building bridges mean because they form teams with each other from different disciplines. They otherwise would not be in the same class. They may not be in the same dorm, but they're working on projects that sort of really extends that. We've launched a society series, and we were talking about Father Paolo Benanti, and his picture is there with us. We have really galvanized our research programming and the grants that we have written together, the grants that we have gotten funded together, and those are necessary. Right? To do the work that we do, grantsmanship is part of doing that business. So we really applaud it. We are grateful for our corporate relations partners, and Ken, thank you for your team and the work that you do with us. We really are blessed, right? I think we're just lucky that we have some amazing folks, students, scholars, partners, all across campus, from Office of Research, from corporate relations to development, that things just happen, right? And I just happen to be an amazing bystander. I think I just was on this train, and I'm riding the train until someone tells me, asks me, where's your ticket? And they would say, I don't qualify to be in this train. So until then, I'm gonna be in this train. Don't ask me for my ticket. I'm without a ticket right now. So I'm gonna ride this. So if we could go on to the next slide, please. All right, so I think a few things that we have done over the last 1 year. We never in the history of our university had a community of postdoc scholars co-located, sitting together, mentored by different faculty members. But it's the right thing to do. These are a community of learners. So if you see your name over there, could you please stand up and let's applaud you. Come on. All the postdoc scholars, if you're here. And what's amazing about these postdoc scholars is that while they're co-located at Lucy, they're mentored by faculty all across campus. Right? I see Jason and I see Maggie as their mentors from business and biological sciences. And, so I think and Mang Jiang, I saw Mang as well, mentoring a postdoc here. Mang, thank you. A postdoc scholar with us. So I think it's because we know that to advance scholarship and to really, push what we believe in, and these are our future leaders, and the community is so important for these postdocs to connect with each other, to build a programming, and to really then tell a story of why I went to Notre Dame as a postdoc. So the next year, 16 come, 24 come, right? So that's what we want to build, that this is the place where you can be mentored by different faculty members, drawing their strengths from sciences, engineering, or business, or global affairs, policy, but you're doing amazing work together. And that, again, is what Father Bob has challenged us all to do, is build bridges, form a community of learners. And that's an important step in that direction. Could I have the next slide, please? And then something else that we are really trying to do is that through the gift of Lilly Endowment, we have been able to found the Applied Analytics and Emerging Technology Lab with Rick Johnson is managing with his amazing team, and we're building this data platform because again we want it to be a place where access to data should be easy. We are data in society. Now imagine social science colleagues of ours or science colleagues or engineering colleagues if we could accelerate their ability to ask questions, to pursue the hypothesis that they want to pursue, where they don't have to worry about where is the data. I'm going to spend 9 months, 12 months getting data. Where we say, hey, we got you covered. Just do your science and scholarship. Get those amazing papers. Because what, our university mission, what Father Bob, Father John, before him, and then Provost McGreevy says, we want to be the best global Catholic university in the world. It's a global Catholic university, so I guess in the world is redundant, but best global Catholic university, distinct but at par with the best private universities. What does that mean? We have to do amazing scholarship. But they've also challenged us a bit more. Do amazing scholarship and be a force for good at the same time, because that's what makes us a global Catholic university. So we have an extra responsibility with us, and this is what we want to see, that how can Lucy help support, and that motto is one of those ways that we're helping support this. And again, the team is working hard by balancing different things, and I'd like to acknowledge all of you. Folks who are working in that motto, could you please get up and receive an applause from us? Thank you. Next slide, please. So hang on, I have a few more things that I need to cover, because my note says I have to cover 3 more things. It wasn't in the slide. I should review the homework. Sorry, Christine, you asked me to review the homework. So I think so there's 3 more things I'd like to share with you. Last year, we integrated, which was our delight, the Center for Civic Innovation, which became the Lucies Civic Innovation Lab at Notre Dame. Jay Brockman, Fred, Jen, and this lab is a gift. The summer programming that they do, the success that they run through in their summer programming, the students they engage with, the impact they're having on South Bend as a community, as a region, and that's also something that Provost McGreevy has challenged us through the strategic framework. South Bend is important. So if our friends from Civic Innovation Lab, could you please stand up and so we can applaud for you. Thank you. And the reason we are calling them labs and building these labs is because it gives a community. Right? It gives a well-defined community, an area of focus, an area of excellence, an area of engagement. Along the lines, we launched the Geospatial Analysis and Learning Lab, which is directed by our chair of our annual planning committee, Matt Sisk. Please, Matt, of course. And then he's working with Ali. Ali, please. My favorite software engineer. So we launched that, and again, the idea was that we wanted to be a place where folks thinking about geospatial analysis and classes in education, etc. Then this year, we started thinking about the challenges that the field of AI awaits us, and we launched, it's formal now, we have launched 2 new labs. One is the AI Trust and Reliability Lab with Adam Sachka from computer science would be heading up. And then I know Toby's in the room. Human-Centered Responsible AI Lab that Toby Lee would be heading up on behalf of the university at Lucy Family Institute. So, Toby. And Toby was a hardball to recruit. I still remember he and his wife were going to go to UIUC. And I said, hey, on your drive to UIUC from CMU, from Pittsburgh, Notre Dame is on the way. Come spend 2 hours with me. It was COVID. And I said, it was winter. It was snowing. I said, you tell me you want to meet outside or with masks inside. I said, I'm better if there's no mask because I can be more expressive. And they were literally going to close the offer, and he's a star. He's a superstar for us, and so as many other folks here, but I'm singling him out because I'm talking about him. And I said, hey, Toby, what's up? Come spend a few hours. And I remember that cold afternoon. It was dark and inside our center offices because we weren't supposed to be on campus. We broke many laws, rules to be there. And Toby is here with us today, and thank you, Toby, for believing in what this could be several years ago and being so successful. And then there's also, thank you. And then it's also, I know I've shared it with the Lucy folks, but now it's official because she has signed. And I put the pressure campaign for her to sign as soon as she could. We didn't let her be alone without signing it. Jasmine, Valia were crowding her, hey, you need to sign now. It expires like 30 seconds earlier. My friend Michelle Martin is joining Lucy as the executive director of the Institute. She graduated, she's a double domer, spent decades at Accenture, and she said she graduates from Accenture, and we said we only take the best. So we need Notre Dame double domers and Accenture graduates to come join us at Lucy. And I've been courting her for a long time, trust me, to join us here. And she's been great already, the things that she has done for us at the Institute, and we were sitting on the table, and she did a theology grad studies, and Father was saying that, hey, that's awesome, we need more theologians in Lucy. I said, I agree. So we are keeping a seat warm for Father Grove at Lucy as well. I'm just saying Father Grove. But again, all I have to say is thank you, and now I am done. I have to bring Matt Sisk back. How did I do, folks? I was over by a few minutes. Thank you again. Congratulations. And Matt's going to announce the Lucies. And just to give you all, before my good friend Matt here comes, and first thank him for, and the committee who did this annual planning. Could you all please stand up here? Everyone. And the entire Lucy Family Institute, you all deserve an applause from all of us. Could you all please stand up? Everyone. All right, thank you. So Matt's going to announce the Lucies, and we launched the Lucies last year with the idea that they're Oscars and they're Grammys. We need something cooler. We call them the Lucies. Now, at one point in our lives, we will get to the budget where we can have envelopes and it's a suspense where we show you the trailers, clips of every nominee. We don't have that budget, my friend. So we know who won it. We will only have one video. But thank you for your nominations, and they are nominated by all of you, our campus community, who the Lucy winners would be. And my friend and colleague here, Matt Sisk, is going to do the honors in opening the envelope, although the envelope is already open. So if you want the suspense, just contribute to Lucy, gifts. We accept all kinds of money, PayPal, Venmo, checks, and then we can have a bigger video budget. I'm just saying.
You're going to stand up here and hand him?
Yeah, he wants me to stand here.
Yep, you stand right there. You're going to hand him. So I think we all need to give Nitesh a round of applause for keeping his 10 to 15 minute talk to only 25 minutes. So
5 to 10 minutes.
5 to 10 minute talk to only 25 minutes. It was really good.
Dude,
Yeah. Okay, so we're going to go ahead and start with the poster awards from the posters that everyone just saw upstairs. And we're going to start off with the undergraduate poster award winner, which is Ways to Better Serve Foster Youth in South Bend, with Christian Farrells, Lindsay Ronnie, and Kate Scheineman. Yeah, come on up.
Carla, you should join them too. You're the faculty member.
Well, you each get one. So.
You join us.
Okay. Okay, and our winner for the graduate student poster is All Female Teams Produce More Disruptive Work, Evidence from Scientific Papers by Nandini Banerjee. I don't know. I don't have that.
There's a lot of truth to that poster, by the way. There's a lot of truth to that title, All Female Teams Space. Best word.
Wow, thanks.
All right. So that moves us. I have to apologize. We do not have a postdoc award. So thank you for the postdocs that gave the posters. But we're going to move on. Yeah, we're going to move on to the Lucy Societal Impact Awards, and these are the ones that we give to recognize individuals or teams whose work exemplifies the vision to inspire collaborative, equitable, and impactful data innovations as a global force for good. So we have 3 of these that we're going to award tonight. And our first one goes to Developing Language Technologies for Kishwa from David Chiang and Chihiro Taguchi. Yep, I think they're going to. Well, let's give it. And for each of these, we have a short video that highlights the work as well.
Imanashamashikuna, kunan kay pachapi, kanchi, mashi chihiroan kay salesiana, hatun yechana wasipi, kichwa shimi, remaikunamanda, hatun dana nahuita, charirka, mashi chihiro.
Imanashamashikuna.
As computer scientists, we are interested in using the technologies that have formerly been developed for large languages like English or Chinese, and using them for really 2 purposes. One is to help to gather information that's of scientific interest about languages that are endangered or in danger of going extinct. And we're also interested in using these technologies to help to revitalize these languages in the communities that are interested in using these technologies to promote their languages.
It was very important that Quechua had its own first language resources data set because Quechua is primarily a spoken language rather than written. But speaker communities wanted to write it down and do some standardization. We actually went to Ecuador and made some presentations to local people in local workshops, and we received positive feedback. They were happy about the quality of the speech-to-text model that we built.
So we were focused on building new models, new technologies, using existing data sets. And what I find really exciting about Chihiro's work with the Quechua community is that he has gone out there, built up relationships with the community, showed them the things that we're able to build, and gotten such great feedback about the usefulness of what he's building and demand from them for more. And that is really beautiful to see.
So the next step would be first to expand the data set, and second, to create more apps or models with broader tasks.
Shupun chakaman.
Shukun Chakama, Ipachani.
Okay, our second Lucy Societal Impact Award tonight goes to Automation of Reports and Consolidated Order Systems, ARCOS, a user-friendly platform to access a comprehensive nationwide opioid database. This is with Rick Johnson, Russ Morris, Michael Kennel, Ramandeep Makija, and Mara Lucas on behalf of Leo, with Bill Evans, Ethan Lieber, Brendan Perry, who could not attend tonight.
we're a Catholic university, and we're interested in figuring out all the ways that people can flourish as a human. The drug crisis since 1999 has claimed 1 million lives. It's kind of the antithesis of human flourishing. So finding out the reason why this crisis has occurred, can we do anything about it, are sort of at the root of what we're trying to do here at the university.
So with any kind of large data, you really have an issue of once you download the data, can you even open the file? Because ARCOS has over 750 million records, it was impossible for researchers to interact with directly.
The information is incredibly detailed. It'll have the date of the transaction, how much was shipped, what kind of drug it was, who the recipient was. It goes from 2006 to 2019, so it's incredibly detailed information. If you want to know how much oxycodone was shipped from manufacturers to distributors or from distributors to hospitals, you can easily calculate that for any jurisdiction or any time period that you want.
And by allowing the researchers themselves to input the parameters and select the data, it gives them a way to get down to the questions that matter most to whatever their research question is. We're working with campus partners already currently to build out a large data platform, and this data extraction service that we built for ARCOS is something that we now look to apply to many different data sets.
Okay, and our final Societal Impact Award for tonight goes to Transportation Insecurity and Rideshare in South Bend, Indiana, by Toby Lee, Jay Brockman, and Matt McCollum.
So the project really aims at addressing the issue of transportation security for low-income neighborhoods in the city of South Bend.
This is a huge problem across St. Joe and Elkhart counties. It's interesting that we have jobs that are spread out all over 2 counties, and we also have people that are spread out over 2 counties, but they don't necessarily live near where their jobs are.
Research has shown that it's number 2 reason why low-income workers are absent from work, only after the lack of adequate childcare. So we think addressing the issue of transportation security for low-income workers is a very important step towards ensuring them having equal access to economic opportunities.
When we started looking at the data, initially we really did not know what it was going to show. We had, a large collection of data from Uber that consisted of where were all the calls for people that were requesting rides, where were the drop-off points, what was the time difference between when they initially placed a call and when they arrived at their destination. And we did find that there were parts of the city where the wait times were longer than others. So if somebody in an outlying area is looking for a ride, they may have quite a wait.
Transportation really is an integral part of our society that's often taken for granted. We started doing a lot of this reading, interviewing Uber drivers to understand incentives in this gig economy, what motivates drivers to take certain rides. We learned about how certain drivers are incentivized to stay in downtown areas or near airports or other high traffic areas, which can serve very much as a detriment to people that are trying to get to work or are trying to get to medical appointments.
Now we are working with members of local community, stakeholders, and community organizations to co-design ways of how we can incentivize drivers to provide more equal access to those low-income neighborhoods, and how we can design different mechanisms to basically build up this trust between drivers and riders.
I think just looking at what we can do, mapping out, planning out, simulating what happens if there are fewer cars on the road and ride-sharing options are more prevalent than they are in South Bend right now. What could that mean?
I'm just going to introduce the teacher. Yeah, you go for it.
Is there something else now? Oh, give me a 2 minutes. All right, so it's not in the program. I'm jumping in because I felt so inspired looking at all these videos. And something that was really compelling is, I think, first of all, the committee and the nominees and everything that was done, the work that was done to put this together. It turns out there's a winner from an impact in our local communities, South Bend, Elkhart. There's a winner that's tackling a national challenge of opioid. And there's a winner that's addressing a low language, low resource issue globally. And that's something that Dr. Govindraju in his talk was talking about, like, what is it that humans can do better at machines? And when there's no data, the machines can't do anything, right? So it would be those languages would have no representation other than if they were not the good work that you guys were doing. So thank you from a global perspective. And I'd also like to acknowledge Christine Gastron. Where's Christine? Please, Christine, for the work she did with putting these videos together. And then also, even though it's not a new news, because she was already part of it, but we've just officially, with the Provost Office permission, we have renewed Fanny Year as an Associate Director for the Lucy Family Institute. Fanny, are you? Since it's not a new lab, it wasn't in the notes, but we just renewed her because her term was. So thank you, Fanny, for all the amazing work you have done on behalf of the Institute. And I know there'll be more announcements coming in. My good buddy Tim Veninger is creating some good mischief with some global leaders. So there'll be some things that he'll be bringing to fore next year as well. So again, I'm pumped, and I should go sit because I'm taking your time, so go ahead. Thank you. And you still have this phone. If you haven't missed your phone, it's an amazing event that you didn't even think about your phone. So I'm just saying.
All right, thank you, Nitesh. I'd like to remind everyone that the centerpiece, those are gift bags, so please take those. But aside from that, that does bring us to my absolute favorite part of the evening, and that is the moment that I get to hand over chair duties to the incoming chair. So I'd like to welcome up to the stage Dmitry Zaitsev, who is going to be taking over as the incoming chair of the 2025 Lucy Annual Celebration.
Thank you, Matt. So, and I'm excited to announce the new theme of the next year's Lucy Annual Celebration that you can see on the slide, that is Inclusive AI for the Common Good. So, several more announcements, actually. It will be in a year or so, but we have some immediate events. So please join us at our upcoming society seminars on October 30. You have the slides. And on November 20. And now let's turn to the thank you. So I want to thank the Corbett Family Hall team for hosting us here tonight. Let's give a round of applause to the venue. A big thank you for Experience ND for organizing today's events and the wonderful dinner. And actually, Nitesh stole my words. That is, I want to express my gratitude to the annual celebration organizing committee. And please stand up, Matt, Katie, Christine, Jessica, Martha, Margaret, Vadim, Yang. Thank you very much. And actually, we have a great team of volunteers who are actually the whole Lucy Family Institute team. So stand up again and let's give a round of applause to you. Thank you.
Yeah, this seems highly unfair, but that is the end of our programming. So thank you all for coming out tonight and helping us celebrate a really impactful year in the history of Lucy. I think this is one of the ones where we've really kind of transitioned from a startup into something that's really kind of keeping the momentum going. And it's been incredibly incredibly rewarding to be part of that journey. And also I'm being reminded again, please take your gifts. And if the Lucy team could remain for a picture, that would be great as well. So, thank you all.